Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 8, 2025, just yesterday, and this paper tackles why video generators fumble multi-object interactions and how to fix it. The big move is a lightweight regularization called matrix that aligns the model's attention with tracked object masks, boosting interaction fidelity and semantic alignment while cutting drift and hallucination. The paper is titled Matrix, Mask Track Alignment for Interaction-Aware Video Generation, and the implications for model training are quite significant. Beyond the method, the work introduces the Matrix 11K dataset, reveals interaction-dominant layers inside video diffusion transformers, and proposes an interaction-aware evaluation called InterGen-Eval. Also, the authors shared a GitHub repo. It hosts the official implementation with a brief README outlining Matrix and an images folder for visuals, but the core training and inference code and model weights aren't uploaded yet. They note that both the main code and InterGen-Eval tools will be released soon. Alright, Figure 1 illustrates the core idea that aligning model attention with object mask tracks leads to more faithful interactions in generated videos. Mask tracks mean per object masks linked across frames, so the model can follow who is doing what over time. The left panel outlines the matrix training setup that nudges attention toward these tracks. The right panel contrasts baseline failures with matrix successes, where attention concentrates on the boy in the green lid bottle and the resulting frames reflect the intended action. So Figure 2 shows failure cases that motivate the method. The panels illustrate semantic grounding mistakes, where the model mislocates subjects or objects or misbinds the action, which leads to text-video mismatch. The panels also depict semantic propagation breakdowns, meaning the correct bindings do not persist over time, so characters duplicate or hallucinated objects appear. Together, these errors highlight why aligning attention to tracked instance masks is necessary. So Figure 7 presents how Matrix trains a video diffusion transformer to lock attention onto tracked subjects and objects so interactions stay consistent. The left side sketches the overall pipeline, where the text encoder, first frame maps, and LoRa-tuned blocks feed two supervision heads. On the right, Panel B extracts video to text attention for semantic grounding, which ties noun and verb tokens to regions. Below that, Panel C extracts video-to-video attention for propagation, which preserves identities across frames. Alright, Figure 7 introduced the training setup. Table 1 now compares methods on interaction understanding and on perceived quality. InterGen-Eval is a structured question protocol that checks whether subjects, objects, and actions are correct across time. Matrix leads the interaction metrics, with KISA around 0.55. It also lifts SGI to about 0.64 and pushes overall interaction fidelity to roughly 0.59. Video quality stays high, with human alignment near 0.95 and image quality around 70, so gains come without sacrificing visuals. Well, Figure 18 shows how InterGen-Eval scores interaction fidelity by checking roles, actions, and temporal consistency. This figure summarizes a three-part process that ties answers to concrete regions and time, so the scores reflect who does what to whom. The central panels list the 10 questions for KISA and the grounding checks for SGI. The right side computes SPI, which penalizes instances that emerge or disappear mid-video. Two takeaways stand out. Aligning attention to mask tracks in the few interaction-dominant layers markedly strengthens grounding and propagation, and a focused dataset plus a concrete evaluation makes those gains measurable. The broader implication is practical, more faithful, controllable text to video generation without sacrificing visual quality. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.